Jai Hind, Vande Matram. This is Kunal Mehta from Make Me Scientific, and I'm back again with CBSE Standard 10 Physics. And I'm going to solve all the back-end question of chapter number 9, that is reflection and refraction. So this is basically an exercise. I will give you the deepest, clearest picture which I'm trying to possibly do. So question number 1 says that which one of the materials cannot be used to make lens? Now first of all guys, see, lenses are always made up of transparent material, so clay is never transparent, so I'm going to opt out that particular part. And if you see the others, right, you will possibly find that water, glass, plastic, all of them, they are transparent. So any transparent material can be used, but the you can't ever use the opaque objects. So clay is one of them. Now the next question states that the image formed by the concave mirror is observed. Concave mirror is virtual, erect, larger than the object. And of course this is only the case that when suppose you have the mirror like this, and this is R, this is center of curvature, this is focal length at half the distance, this is the pole, and if you place the object in between the pole and the focus, you get a highly enlarged image behind the mirror like this. Correct? So that is possible in D option, between the pole and the principal focus. Right? If you don't have any knowledge of the ray diagrams and all those stuff, please click on the link which is given in the description. You will get a very good the clear picture of the ray diagrams and all the other stuffs, right? So I must insist that before seeing this lecture, you might want to study the ray diagrams in order to get a better understanding. Let's move ahead. Where should be an object placed in front of a lens to get a real image of the same size? Now that is only possible, guys, that if you have a convex lens and then you are placing the object exactly at 2f. So this is f, this is 2f, here again that is f, this is 2f. So if you place the object at 2f, you will get the image of the same size on the other 2f, on the other side of the lens, of the same size, right? So here you can say that the magnification is 1, but in this case you will get magnification -1. Magnification +1 is a case of plane mirror. So few things that you need to remember are the following: that in case of lenses, f, twice of f is not equal to the radius of curvature. This is not possible in lenses. Please students, don't make any blunders over here. In case of lenses, double the focal length is not radius of curvature. One more thing, yes, radius of curvature is double the focal length in case of mirrors only, but not in case of lenses, because in lenses 1 upon f is equal to mu minus 1 upon r1 minus 1 upon r2. So this is never a case in lenses. This is lens maker's formula. Just for your knowledge, I am saying in lenses this is not possible except one case, but we will not discuss over here. Please remember, r is not equal to 2f, but r is equal to 2f in case of mirrors, whether it is concave mirror or concave mirrors. Yes, focal length is infinity for the plane mirrors, but this question I hope will not come, right? But still, just for an extra thing, these are some tips. Question number 4. Question number 4 says that a spherical mirror and a thin spherical lens have focal length of -15 centimeters. Now see, how do you remember which is positive focal length and a negative focal length? I'll give you a very easy example. See, first of all, you draw a number line. So I'm going to draw two such number lines. I mean, this is not a number line basically, but this is a coordinate system. So this is y and x. So you draw two coordinate systems, y and x. And this is the origin O. Okay. Now, whichsoever lens or whichsoever mirror you want to put, you put it over here such that the optical center of the lens should be at the origin, or if it is mirror, its pole should be at the origin, right? So if I draw concave mirror, I will have to draw concave mirror like this, such that its pole is at the origin, and concave mirror has reflecting surface inside like this, and the painted surface is this dotted surface which is outside. But if I want to draw a lens, I will have to draw a lens like this. Suppose if I draw concave lens, I will draw the lens like this. Now you know that the objects are always on the left hand side. So if I keep the object here, right, you will see that the rays will come and the ray will be parallel. After hitting, it will pass through the focus. So here is your focus, and you can see that the focus is on the left hand side of the origin. So that means the distance from the pole to the focus itself will be negative. So the focal length of concave mirror is negative, whereas here let's take an object like this. So if you pass a ray parallel, you know that it's a diverging lens, so it will diverge like this, and if you extend the ray backwards, you will get the focus. So again, the focus is on the left hand side of the origin, so this is the focal length which is going to be negative. So this is how you can remember it. And in case of convex and concave, convex mirror and convex lens, focal length is going to be positive. So A option is the right answer. No matter how far you stand from a mirror, your image is always erect. First is plane mirror. See, in case of plane mirror, when you stand at a distance of say 2 meters, then behind the mirror 2 meters of the same height, your image will be formed and always erect. First is this case. And then in case of the convex mirrors are like this. And suppose this is, if you complete the circle, you will get this as C. This is the pole and halfway is the focus. And guys, you need to remember, you put the object anywhere on the principal axis, you will always get a virtual erect image behind the mirror between P and F. Always a erect image, virtual image, smaller size image between P and F. Yeah, the position of image will be slightly moving in either of the directions, but it will never go behind F. So this is the answer to the problem. Sixth, which of the following lenses would you prefer? See, there are multiple solutions available in the internet, but what I feel correct is what I'm sharing with you. See, first of all, if you use the convex lens, here please do not say mirrors, because mirrors, you can't look into the mirror and magnify the things if the object is behind the mirror, right? That can't happen. Lenses are transparent. Now, if you keep the object, suppose this is O, this is F, you keep the object here, you will get a magnified image here, and your eyes are here. Correct. This will never happen in case of concave lens. In concave lens, always you will get the smaller image. So when you read the letters of the newspaper or the letters of the dictionary, they are very small, they are object. Now you keep the lens between your eye and the letters. The letters must be between the focus and the optical center, and behind the object you will get a larger image. So your eyes will not be seeing the small letters, it will be seeing the image which are bigger. Now what I feel correct is the magnifying power. Now since this concept is not given in grade 10, magnifying power is 1 plus d by f for convex lenses, where d is the least distance of distinct vision, that is 25 centimeters, which is constant. So you can see that lesser the focal length, higher is the magnifying power. Magnifying power means by how many times the image gets magnified. It's not a regular magnification, it's an angular magnification, right? So I should be saying that since this is not a part of your syllabus, this is the correct answer. But there are several solutions which say that power is 1 upon focal length, and if you have a less focal length, the power of the lens becomes comparatively larger. But I don't see any sense in this one, because thicker the lenses, more powerful they are, they will bend the light more. Apart from this, I don't think that there is any other logical think behind this particular answer, but still you may write that power is inversely proportional to the focal length. So lesser the focal length, higher is the power. Okay. Question number 7. We wish to obtain an erect image of an object using a concave mirror of focal length is. So first of all, that if you want to have an erect image, there is only one position, that is between the pole and the focus. So sorry, you keep the object here, and then if it is a virtual images are always behind the mirror. You will get the image like this. Correct? This is object, this is the image. The image is magnified behind the mirror, right? Now they are saying that the focal length of the mirror is 15 centimeters. What should be the range of the distance of object from the mirror so the object can be placed anywhere between P and F? So I should be saying that the object distance U should be less than, equal to, not even equal to, because when you keep the object at focus, it becomes, the image goes to infinity. So U should be less than 15 centimeters. Okay, so this is 15 centimeters. So you can keep the object anywhere from 0 centimeter. If I say 0 is at P, so 0 to 15 anywhere you can put, not exactly at 15 centimeter. Also in that case the image will be at infinity. Right? Now, is the image larger or smaller? Answer is magnified. Nature of image, it is erect because it is behind the image. Now in case of the image formation, right, you may please click on the link below and see how the image is being formed. Still, I'll give you the very rough idea that you may, this is your concave mirror, not to the scale, but still I'll try to draw it. This is the focus and this is the pole. First ray parallel passing through focus like this, and the another one goes to the pole, and then at the same angle it goes like this. Extend both the reflected rays backwards and you will get a magnified image over here. There are multiple ways. This is one of them. Other rules you can also apply. If you want to know about them, please check out the link which is there in the description. Name the type of mirrors used in headlights of the car. Very good question. See, in the cars, mostly what happens is, drawing a very rough picture of a car over here like this. Now, there are headlights here, right? Now, our aim is when you turn on the headlights, the light must go to a very long distance. That is only possible if you have something like this. See, this is a concave mirror and I'm putting a very small bulb exactly at the focus. So multiple rays will fall on the concave mirror, and after reflection the rays will become parallel, and parallel rays go to a very long distance. That's why we say the headlights of the car must have concave mirror. Side view, rear view, you should always have a convex mirror, because convex mirror, they have a larger field of view. You can see wide view things in a very small mirror. Apart from this, when you are driving a car, you don't have to look backwards to see what is coming from behind. You always have to see the rear mirror, and when you see the side mirrors or the rear view mirror, the mirrors which are there in the two sides of the car, when you see them, you will always see a car coming from behind or a tanker coming from behind, very small but erect. If you use a concave mirror, you will see an inverted car, in that case you will blow up your mind. You will not be able to judge at what distance it is. So first thing is larger field of view, and you get an erect image. Imagine a bus coming from behind which is inverted. You would literally get afraid in case of a concave mirror, right? Plane mirror we will not use because you can't see a wide thing into that. You can use a plane mirror, but that restricts the other sides of the car or other sides of the road coming into that. So very small section you will be able to view in that case. So larger field of view, maximum area will be covered. That's why. The third is the solar furnace. Again, in the case of solar furnace, we take a huge mirror like this, concave mirror, and then we know that this point is the focus. And then from the sun, all the rays of light will come parallel and then they will meet at focus. So what is going to happen is all the sun rays meet at focus, so the temperature at the focus becomes very large. So if you want to heat something, if you want to melt a metal, you can keep exactly at the focus, and due to a large surface area, large rays will fall, gathering at a very small area at the focus, and huge temperature rise, and the thing which you put over there will surely melt. So these are the things, right? Okay. One half of the convex lens is covered with black paper. Will the lens produce complete image? Answer is yes. Verify your answer experimentally. Okay, but I'll still say that if you have a convex lens, what happens is, suppose there is an object, or maybe the object is at infinity, right? So in that case, all the rays will be parallel, and all those parallel rays will meet at focus. Like this, all the rays will meet over here. You will get a very bright image of the object at infinity. But now imagine that if you cover the half of the lens, the bottom part, with black paper, so these rays which are coming from the bottom will never come and reach on the other side. So still you will get the complete picture, because the upper half of the lens is still into action. It will collect all the rays, it will produce the entire image, but the image this time will be faint, it will be less bright. See guys, if you have spectacles, cover half of your spectacles, you will still see the complete image, but it will be less bright. That's the correct answer, right? So even if you take a very small section of the lens, it will still produce the complete image, but it will be less bright. Alright, let's solve question number 10. The object is 5 centimeters in length, so that means height of the object is 5 centimeters. Since the objects are always erect above the principal axis, so their lengths or the heights are considered as positive. The object distance is always negative, and the lens is converging. It means it's a convex lens, so the focal length is positive. We are supposed to find the position, nature of the image, and size. So first of all, position means the image distance. So we'll use the lens formula. 1 upon 10 is equal to 1 upon V minus of 1 upon minus 25. So this, when it goes on the other side, 1 upon 10 minus 1 upon 25 is 1 upon V. So this is 15 upon 250, 1 by V. So V is equal to 250 divided by 15. So basically 5 5s are 25, 5 3s are. This is 16.6 because 16 3s are 48. So 16.6 centimeter would be roughly the image distance. Now the image distance is coming positive. That means the image is formed on the right hand side of the lens, opposite side of the lens. Now the nature of the image is real and inverted. See, how can I say that? Is due to the following. Like this. This is your optical center. The focus is 25 centimeters. No, the focal length is 10 centimeters. So this is 10 centimeters. So definitely 2f is 20 centimeters. So you can very well see that the object is 25 centimeters away from the optical center, which means the object is beyond 2f. So if the object is beyond 2f, on the other side, between f and 2f, you will get the image. So this is 10 centimeters and that is 20 centimeters. So your answer, the image must be a little bit smaller, real and erect as per the ray diagrams, and it should be between f and 2f. So the answer turns out to be correct, which is 16 centimeters, which is between 10 and 20, right? So this is how you can judge. Now the complete ray diagram I'm just leaving on you. You can simply draw two rays and find out the image, right? The size of the image, so basically magnification is equal to Hi upon Ho, that is equal to V by U. So now let's substitute Hi, that is the height of the image, upon height of the object is 5 centimeters, which is positive. That is equal to V by U. Now V I am going to take positive because the V was positive in the case over here. I am going to take 50 by 3 so that it can be cancelled easily. U is negative. You need to use sign convention very carefully here, right? So minus 25. So Hi is equal to 5 multiplied by 50 divided by 25. Minus sign comes up into 3. 1s are 2s are. So 5 2s are 10 divided by 3. So the answer is minus 3.33 centimeters. That is the answer to the problem, the height of the image. Now here we are given concave lens of focal length 15 centimeters. So in concave lens, the focal length is negative. Then forms an image 10 centimeters from the lens. Now the image is always virtual in case of the concave lens, and virtual images are formed on the same side of the object. So the image distance will also be negative in this case. So I'm saying something like this. Here this is F, here this is O, and if you place the object at say 10 centimeters, no, we don't know where is the object, but the image is always formed between F and O, and this distance is 10 centimeters and the focal length is 15 centimeters. You may put the object anywhere and you will always get the image. This is the image between F and O. So image is also on the left hand side. That's why the image distance is negative, minus 10 centimeters. You are supposed to find the U. Okay, so let's use the lens formula. 1 upon F is 1 upon V minus 1 upon U. 1 upon minus 15 is 1 upon minus 10 minus 1 upon U. Shift this on the other side, minus 1 upon 15 plus 1 upon 10, that is minus 1 upon U. So this is 1 upon 10 minus 1 upon 15, just rearranging, minus 1 upon U. So this is 15 minus 10, up, that is 5 upon 150, that is minus 1 upon U. So which gives you 1 upon 30 is minus 1 upon U. On reciprocating, you get the image distance, sorry, the object distance as minus 30 centimeters. This is the beauty of the sign conventions. You will get the answer with the sign. So the object is now placed at a distance of like 30 centimeters. From O, this distance is 30 centimeters, right? So the object distance is 30 centimeters. You may draw the ray diagram completely like this. Any diagram is fine. You may put the object anywhere. Since I am drawing with freehand, the diagram would not be so good, but you may keep the object here. First ray parallel, it would be diverging like this, second passing through the optical center, and the image is here, right? This distance is 10 centimeters, and triple the distance is U, that is 30 centimeters. That's it, right? Let's move ahead. An object is placed at a distance of 10 centimeters. So object distance is always negative. But from convex mirror, and by the way, everybody should understand that convex mirror has a reflecting surface outside, and the center of curvature and the focus are on this side. So the focal length, this is the pole, and the focal length is going to be on the right hand side. So that means the focal length of this lens is positive, 15 centimeters. So I'll take convex mirror, focal length as 15 centimeters, right? Find the position and the nature of the image. Please note, this is not a lens, this is a mirror. So 1 upon F is equal to 1 upon U plus 1 upon V, right? So 1 upon 15, that is equal to 1 upon minus 10 plus 1 upon V. Shift this on that side. So 1 upon 15 plus 1 upon 10 is 1 upon V. So this is 25 by 150, that is 1 upon V. V is 150 divided by 25. 5 30s are, 5 5s are, 5 6 are. 6 centimeter is the answer, which means the object is placed here, always left hand side to the mirror, and this distance is 10 centimeter, and the image is between P and F, somewhere over here, diminished. We know that as per the ray diagrams. And from P to F, the distance, sorry, from P to the image, the distance is 6 centimeters. That is the image distance, right? So this is how the things happen. Okay. Now, in the next question, they are asking, magnification of a plane mirror is +1. What does it mean? See, it basically means that if you are standing in front of a plane mirror like this, your height is, suppose height of the object is 1 meter. you will get the same size image behind the mirror like this, and the image height will also be erect and it will be 1 meter. Now, if you look in terms of the object distance and image distance, this is object distance u and this is image distance v. Both will be same. Now, magnification is hi upon ho. So height of the image, all height above the principal axis are positive. So the person and the image of the person are above the principal axis. So plus 1 meter divided by plus 1 meter, the answer is going to be plus 1. In case of the concave lens, also the magnification is positive but always less than 1 because the image is smaller. So this is what it means. The height of the object image are same and the image is erect. This is what it means. An object 5 centimeter in length placed at a distance of 20 centimeters from convex mirror. So u is equal to minus 20 centimeter and radius of curvature, radius of curvature is 30 centimeters. Yeah, so the focal length is radius of curvature divided by 2, so that is 15 centimeters. Since the mirror is convex, the focal length is positive. Now find the nature, size of the image, position of the image, which means I will find v first. So I'm going to use the formula 1 upon f, 1 upon u plus 1 upon v, 1 upon plus 15, that is 1 upon minus 20 plus 1 upon v. Take this on the other side. So this is again 20 plus 15, that is 35, divided by 15 2s are 30, so that is 300, that is 1 upon v. So on reciprocating I get 300 divided by 35, right? So this answer is probably less than 10. So let me divide this. 5 60s are, 5 7s are, 7 1s are, 7 8s are 56, 4 7 5s are 35, 7 6 are 8, approximately 8.5 centimeter I should be saying, and that answer is coming positive. So this is the v that we have found out. Now we are also supposed to find out the nature of the image. Now see, always in case of the convex mirror, the image is formed between P and F, behind the mirror, and behind the mirror all images are virtual and direct, right? So we are supposed to find out the nature, so virtual and direct. Size, so basically magnification is hi upon ho, correct, and that is equal to v by u minus, now using the sign conventions, the height of the object, the length of the object or the height of the object, and object is always, see, if I draw the object height is always positive because it is above principal axis. So hi we don't know, height of the image, that should come positive because it is an erect image. Height of the object is positive 5 centimeters because it's above principal axis, minus, now v itself is positive, so it is about 8.5 centimeters, or we can also write down 300 by 35, correct? So one and the same thing. So if you want, you can write down 300 by 35 divided by, oh by the way, answer was positive, v divided by u, sorry, this is minus v by u, so this is v is positive but minus sign is in the formula, divided by u is again negative, and how much that is? 20. So this means height of the image, that is equal to 300 divided by 35 into 20. Now 5 centimeter goes in this direction, so 5 1s are, 5 7s are, 2 1s are, 2 15s are. So the height of the image is somewhere around 2.1 centimeter, 15 by 7, right? So the image is diminished, it is definitely virtual and direct, that's why the answer is coming positive. So this is how it has to be done. Now the object of size, size means the length, or you can call it as a height of the object. So object distance is given u minus 27 centimeter. Concave mirror focal length is given, concave mirror has focal length negative 18 centimeters. At what distance from the mirror should be the screen kept? That means screen means the real image is formed, and real images are always formed on the screen. That's why indirectly they are asking you find the image distance, because image is formed on the screen, right? So V needs to be found out. So 1 upon F, 1 upon V plus 1 upon U, 1 upon negative 18, 1 upon V plus 1 upon minus 27. So minus 1 upon 18 minus 1 upon 27 goes on that side, plus 1 upon 27, 1 upon V. So this is, we may want to find out the LCM. 27. Okay, let me think. Any other short trick? Okay, 18. Now 9 3s are 27, 2s are 18, 3 1s are 2 1. So 9 3s are 27, 2s are 54. So the LCM is 54. 18 3s are, so minus 3 plus 2, that is 1 upon V. So minus 1 upon 54 is 1 upon V. So image distance is, you may see, it is negative. And in case of mirrors, listen to me carefully, in case of mirrors, the negative distance means the image is also on the same side of the object. And that means it's a real image, because in front of the mirror, real images, and real images are always inverted. Now, since you are supposed to be finding the size of the image, and nature is real and inverted, you are also supposed to find out the size. So Hi upon Ho, magnification Hi upon Ho is minus of V upon U. Height of the image we need to find out. Height of the object, or the length of the object, is 7 centimeters. Now Ho is positive because all objects are above principal axis, so plus, please use sign convention very wisely, minus. V is negative, so minus of 54. U is negative, so minus of 18, right? So this is, no, U is 27. So 27 ones are, 27 twos are, minus minus goes. So Hi upon 7 is equal to minus 2. So height of the image is 14 centimeters negative, which means the image is downwards. That means it's a real and inverted image. So this is how it goes. Now, the focal length is to be found out, and the power is given. First of all, negative power means negative focal length. Negative focal length means this is definitely a concave lens. Concave lens, right? Negative focal length is of concave lens, positive focal length is of convex lens. So focal length is equal to 1 upon power, right? And I should be very well saying to you that it is minus 2d. Now 1 upon diopter is 1 meter. So this whole part 1 upon d is basically 1 meter divided by minus 2 remains as it is. So 100 centimeter divided by minus 2. So the focal length is minus 50 centimeters. That is the answer to the problem. Definitely negative focal length corresponds to concave lens. Next. The doctor has prescribed a corrective lens of this positive power. That means it is a convex lens, and convex lenses are always converging unless they are dipped in a liquid whose refractive index is more than that of the lens. In that case, it will behave as a diverging lens, right? So we don't need to go into that much of the details, but now again focal length is equal to 1 upon power, that is 1 upon plus 1.5d. 1 upon diopter is 1 meter divided by 1.5, that is 100 centimeter. So 100 divided by 1.5 is roughly 66.6 centimeter. The answer is positive because the power is positive, right? So I hope guys that this was easy for you, right? If you have any doubts, please do comment in the comment section, and if you haven't subscribed my channel, please do that. Thank you very much for watching the video.